Hi guys, I'm Rajiv here. Can you guys tell me if I'm audible? Aritra and Avanish, two guys are there. Two of you are there. Hello.
Yes, yes, you're audible.
Yeah, Aritra. Thanks. Okay, I'll wait for a couple of more minutes. Maybe some more people may join. So we'll start on after that.
Sure.
Okay, since there are only two of you here, I think I can just. Guys, you are already into data science, or you have just decided to follow this lecture to check out what is data science all about.
Actually, I'm also from Edurega. Yes, yes.
Aritra, you're from Edureka.
It is. I am here for the meeting.
Huh?
I am here for the webinar. I started the webinar.
Yeah, Avanish. Yeah. Sorry. Yeah, you passed on the host connection to me. So Avanish is the only person who is there. Okay. So Aritra, I think we should wait for some more time, or shall I start? Okay. Let's wait for 1 or 2 more minutes. Okay, guys, let's start. I think, okay, guys, let me introduce myself. I am Rajiv. Apart from being an instructor at Edureka, I run a consulting company, small consulting company on data science, artificial intelligence, and machine learning. I am also a regular visiting faculty at Delhi University, Shriram College of Commerce on data sciences. I also teach another business. I have some three, four, five platforms where I teach. Edureka is one of those, and I'm into consulting. I'm a consultant to couple of companies, of which one of which is actually a Fortune 500 pharmaceutical company. So, so I basically train and teach data science and artificial. That's the kind of this thing I have. So, Aditra, are you coming with a data science background, or you are new to it? So let's. Aditra, are you there? Okay. So let me continue. I'm assuming that you are there. Okay. So there's one thing that let me share a few things with you guys. Uh, Let me share a few things. Okay, let me share the screen. Okay, now there's an announcement from Edureka here, which says that like for most of the courses in the webinar, most of the training courses from Edureka, if you're attending a webinar, you get a 20% discount. And you get a 20% discount. So you attend any of the trending courses which are going on, which Edureka offers. And the coupon code is the webinar I webinar 20. So there's a coupon code. So if you want to join any of the training courses, you straight away using this coupon code, you can get a 20% discount. Correct. Okay. So let's get into the real stuff. So we have, let me share a presentation with you. Oh, what is it? Uh, just give me a moment, guys. I want to share a PPT with you. So yeah. So this is so today our topic is LSTM. LSTM is a short form of long and short term memory. It is a type of deep learning network. Now, uh, just trying to jump into what do you call this? Straight away trying to jump into LSTM may not be correct if the person does not have any background of a deep learning or a machine learning, doesn't understand it. So I think I will give a quick heads up on what is machine learning, how what is deep learning, how is deep learning and machine learning different, what are the types of deep learning, and then I will talk about recurrent neural networks. And within recurrent neural networks, there is long and short term memory networks. So we'll talk about this. The agenda typically is like I will also introduce you to natural language processing because uh, LSTM networks are highly suitable for processing natural language for running NLPs, natural language processing. You can also run NLP on machine learning but through machine learning, but LSTM is a very highly suited, and I'll explain you why. Once you understand the architecture of LSTM, you will be able to appreciate why NLP, and you understand a little bit about NLP, you'll be able to understand why LSTM is a very, very suitable platform for running NLP, natural language processing. While talking about NLP, obviously, we'll talk about the various ways the text data is processed. We will talk about recurrent neural networks, but I'll go a little, I'll start from machine learning, recurrent neural networks. Then we will look at what is the architecture of a long and short term memory. Why do we need an LSTM? And then we will talk about some LSTM cases. We'll see some real time applications of LSTM. And see, this is only a 1 hour webinar. And I have a code, obviously, which has been written for, which has been written by this thing. Okay, so Meetup is a community which is which is about 46,000 members now. So Meetup community. So if you are registered in this, you will continuously be getting uh, invitations to webinars for various topics of your choice, and definitely is a very good way to keep up. And I have also told you that if you join any of the training courses of Edureka, you get a straight away 20% discount. Webinar 20 is the coupon code. Correct. Now, having said this, let's and I have also discussed the agenda. Uh, Now, just a little bit about Edureka training. AI certification courses are available. We have instructor-led live sessions. So, like I'm teaching, there will be a instructor to conduct the live session. So it is not one of those, pre-recorded sessions. So that's an advantage with Edureka. Most courses are instructor-led. There is 24 into 7 doubt clearing support. So if while practicing, while doing the assignments, if you have a problem, you get Edureka certification, one of the most recognized certification. Obviously, you get a lot of projects and assignments to practice and to reinforce the knowledge that you get in the classroom. And almost 30 hours of live class for artificial intelligence certification course. This is what you have. So that's a big thing. Okay. Now, next is there's something coming up on this is a little old. September, I think, uh, coming. In deep learning, there's a certification course available. Obviously, the things that are taught is introduction to deep learning. And obviously, we do deep learning on TensorFlow platform. TensorFlow is a library, is a computational library from Google. So TensorFlow and Keras is what we use for, and that is one of the most popular platforms for deep learning. You get a lot of hands-on session. You will learn convolution. I'll tell you about CNN. I'll about regional CNN. That's a special type of CNN for object recognition. Introduction to RNN, recurrent neural network. LSTM is a type of RNN. Correct. And then you get hands-on. Is it LSTM? Correct. So it's a very comprehensive course that you have in deep learning. Okay. So next is what is natural language processing. But before we get into natural language processing, guys, for me, I would like to take you through a quick heads up on what is machine learning and what is so. So let me focus on this. Uh, 1 second, guys. Huh? Okay, so what is machine learning? So how is deep learning from different from machine learning? So typically, machine learning is a way of predictive modeling. So what happens that typically we will have a machine learning algorithm. Machine learning algorithm we will have, which which depending on the case, whether if you want to, if you are trying to predict something continuous, then it is regression. Otherwise, it is a classification model. We put our data, right? So the data goes in. Once the data goes in, the machine using the algorithm learns from there, and it comes up with a model, which is basically an object, which comes up with a model, which is all the learnings that the machine gets from the data are put into this model. And then you put new data, which is not the same data which you trained, you put new data, and the machine will go and predict. Machine will go and predict. This is your machine learning model typically. Okay, so let me put it down. This is what we do in machine learning. Now, obviously, machine learning is is used widely. It has a lot of algorithms available almost for every situation. But machine learning is not as accurate as deep learning. So let's look at what is deep learning. Now, machine learning, the advantage of machine learning is that you don't require huge data to train the model, but it is not as accurate. But for uh, accuracy, you have the deep learning concept, or which is also called the neural networks, which is, don't mind my writing, because when I write on tab, it becomes like this. In deep learning, what happens? Deep learning imitates the human brain. If you see, our human brain is made up of something called neurons. Neurons. Meta is so neurons take in information, process information, and obviously gives output. So our human brain is made up of millions of neurons. So one neuron will typically have an input going in, it will do some process, and it will give an output. So a deep learning network typically would be made of neurons. So maybe I'll just tell you, maybe we have layers of neurons. So maybe we have another layer here, and maybe another layer here, uh, and another layer here. Correct. So typically, this is the input layer. Let's say, let me use something. Let me take you on a let me show you. Right. This is looks like this. Looks like this. I hope you can see it, guys. So typically, a basic artificial neural network would look like this. Correct. So these are, each of these circles are neurons, and the first one is the input layer. Correct. And the second one is the output layer, hidden layer, and the third one is the sorry. One second. Uh, so how does uh, how does a neural network layer work? So typically, what it does is, data which you want to process goes in from this neural layer. Okay, so the data that you want to process goes in through this neural layer, and after this, every layer would, one second, I will, uh, would I do it? One second, guy. Made a mistake. Uh, let me take you back to this thing. Okay, now let me see. Let me take you back. I think that was not working. So we have an input layer. We have these three other hidden layers, and then we will finally have an output layer. Now, output layer, depending on the task, it could be either one or it could be two, and all these neurons will be connected. All will be connected to all. So I'm just drawing a few lines. So this is called a fully connected network. Now the data that is comes in from the input side, input data that comes in, that is processed, that is passed from layer to layer, and at every layer, the network would add would have a weight and would do some processing and pass. So this is called forward propagation. So once the forward propagation comes, once the result is here at this stage, what is the result? The result is eh, matched with the desired result. If the and the difference between this result, which is coming through the network, and the desired result is called a loss function. So obviously the changes are done. So all the weights, and then obviously if this is not perfect, not as expected, the entire data is pushed back through the network, and this is called a backward. I'm sorry, this is pushed back to the. This is called a backward propagation. Backward propagation. Now, in this process, all the weights are adjusted. All the weights are adjusted so that. So this is how a basic artificial neural network works. This is how a artificial neural network or a ANN works. Now, coming back to the same screen which I was showing you. Uh, I'll take you back to that same presentation. Huh. So this is what we have seen just now. We have seen this is a basic artificial neural network. Now, depending on the situation, artificial neural networks could be of different sizes. So this is a relatively, this has one input layer. Mm, See, this has one input layer. Uh, this is one input layer, and this is one hidden layer, one input layer, one hidden layer, and output layer, one output layer. This is a deep neural network. Whenever your number of hidden layers are more than two, then you can call this a deep neural network. This is how a deep neural network works. This is now deep neural networks are one of the most widely used today for predictive modeling, but they have a limitation. Now they cannot process images very well. So say if I am trying to build a model where I am trying to train my network to predict whether MRI scan of a person MRI scan of a person is malignant or benign, then in that case, standard artificial neural network will not do enough. So in those situations, we have something called a convolutional neural network, right? A convolutional neural network, I will just show you, is a little different. It does a lot of things. It processes the images, and there is a convolutional layer added. So if you see, one second, it is very much like this. This is what a convolutional. So an image, which is a digital image, obviously it is in zeros and ones. So this is how a convolutional neural network looks like. So there is a convolutional layer here, if you can see. Then there is a pooling layer. There's a pooling layer. Then there's flattening. After flattening, After flattening, this will go into a standard artificial neural network. Here you see ANN. This is an ANN, and this is the convolutional layer, and this thing. This whole network is called a CNN, convolutional neural network. This whole network would be called a CNN. This is very good for situations where you have images, you have to process images, correct? So you can use a in fact it does better than ANN. Now this is one. Now let us go back to, so we have understood what are the two things we have seen just now. We have seen machine learning. One second, let me go down further. So we have seen machine learning. We have seen machine learning. We have seen deep learning. We have seen in deep learning, we have seen artificial neural network, ANN, and we have also seen convolutional neural network for processing. Now, there is a third kind of a network. Look at this. I'm saying Ravi is a good student. The next line I write, he gets the highest marks in the class. Now, I'm not getting into it. So if you see Ravi, Ravi is a person. Ravi is a person. Now, Ravi, because Ravi is gender is male, that is why we have he. But if it was not Ravi, it was Neha, this would have been she. So in situations, I'll show you like another predictive of LSTM. One second, guys. Ha. Let us look at a situation like this. This is how LSTMs work in natural language processing. So the man is walking. So this the man is walking is processed by the network, and it gives the highest probability word after that predicts, that is down. Then what happens? Sorry. Then obviously the the next four. See, if you look into this, if you look into this, in the second step, actually all this, the man is walking down. See here, see here. It becomes so, and it says the next predicted word is da. So da is the most probable word. So in this situation, imagine a small neural network like this. In any situation, a layer, a layer will need to know what is there previously to predict. So whatever the previous layers are doing, so it is something like this. Say this is a layer. Just imagine there is a layer, and so whatever the input is and the output, it will put the output back into the layer. Because suppose I say Ravi is a good boy, he. So when the layer that is processing he should know that Ravi. So the information from the previous layers, the memory from the previous layers need to come in. Those are typically called recurrent neural network. Here it is. So this is with respect to time. So you see, as time goes, t minus 1, t. So each of these is a layer. See, this is one circle, but actually you can consider there are more number of neurons behind each of these. And so these are layers. So as the time progresses, the output of a layer is fed back into the next layer and also to that layer itself, whichever is feeding it out, so that it has the information about the previous. So these are typical types of application like time series, natural language processing that does it. Here you see there are three layers of neurons. You see, while predicting y out, which is the prediction, it is also feeding itself back with the information. So these are called recurrent. This is another type of network. So if you see, we will add one more to this, and this is a recurrent neural network. Now, recurrent neural networks have a limitation. What is the limitation? That this is limitation is called the vanishing gradient descent problem. It is somewhere here. Sorry, it is somewhere here. I will explain. See, okay, let me also tell you. So this is how typically a recurrent neural network works. So as I showed you, that it is with respect to time. It takes its own input from the previous layer and also passes the input back to itself. So there are various types of there are there are multiple configurations of RNN. So one is the sequence to sequence, many to many. That means you give 5 words similar to the situation here. So you are giving 4 words, you are getting one word out. So you could have another situation where you are giving 5 words and you are getting 5 words out. This is one way. Another is the one we are giving 5 words and you are getting one word out. Correct. This could be you are giving one input, but you are getting 4 inputs out. So these are the types of applications. Like, you see, Google Translators typically works on the LSTM model. All your Siri and all this Google Voice that you do, they are all applications. So one to many is where, with respect to time, is where you give one image of an input. You are giving this image, and it is predicting many words. Black and white jog dumps the bar. So this is a one to many. Then you have many to many, where you write a sentence in Google and it gives you a prediction from the other side in the other language. So this is many to many. This is also many to many is actually many to many is you give multiple videos to network and it will give you multiple subtitles. That is many to many. This is many to one. So many thanks. So this is sentiment analysis where you write something good or bad about a film or anything, maybe a Twitter and send to a Twitter tweet. So there are many words, and but ultimately you get one output, which is it's a positive sentiment or it is a this. So this is how LSTMs work. These are types of LSTMs, recurrent neural network. Correct. Now, recurring neural networks. Sorry, this is not here. Recurrent neural networks have one serious limitation, that is the limitation of vanishing gradient descent. Now, in vanishing gradient descent, what happens is that uh, when the networks are too big, the weights, as the weights are adjusted, the weight size becomes too small and there is not much, it cannot do much changes to it cannot do the necessary changes to the data as the layers, as you keep going on to the layer, something like this. You are always in a situation like this. In a situation like this, uh, where you are already always adjusting the weight. So there's a weight, the weight recurring. The weight is getting adjusted in every layer. It is going from one to one. As it goes up, it goes and it gives an output. And while doing the backward propagation, the weights are adjusted once again. Let me show you this. The weights are adjusted once again while it comes back. So by the time it comes back, then the data goes up, and each stage the weights are adjusted. And while you come back, that is backward propagation, the weights are adjusted again. By the time it comes back, it almost becomes so negligible that it cannot make any reasonable impact on the data processing. So that's called the vanishing gradient problem. Somewhere in the middle, the vanishing gradient is called. For these situations, we have something called vanishing gradient. Here you see we have a long and short term memories. LSTM networks. Now, LSTM networks do help us to uh, get over this vanishing gradient problem. How do we do that? There's a special architecture, though there's a lot of mathematics behind that, but I will try to show you the architecture so that you understand the basics of the working of an LSTM. Correct. So here, this is a standard RNN. So recurrent neural network where data goes from one. See, each of these green boxes is one layer. Each of these green boxes is one layer. So here is a tanh is an activation function. So this is many two. So at each point of time, xt minus one, the A layer does something and you get ht1 is one. This is a typical RNN. But in a LSTM, let us look at the architecture of a LSTM layer. This is how it looks like. Rather, let me put it like this. This is easier. So what happens in a LSTM is, because this is a recurrent neural network and there is a problem of vanishing gradient, the things that the layers, subsequent layers need to know are passed on through this memory cell. This you can see this here, memory cell. Now, like I said, Ravi is a good boy. So in this situation, Ravi is required. The gender of the name is required. So this situation, the information will pass. But if there is a situation like the man is walking down, the down needs to be passed. The man, but we do not need much. Then if that kid, this is called a gate. These are called gates. These are gates which like valves, which open if the information required from the previous layers are needed by the subsequent layers, it will pass through. If it is not required, it will be forgotten, thrown out. Correct. So this is a gate. So this is the data that is sorry, this is the data that is coming in from HT, the previous time step. Correct. And this is the new data that is going into this time. So these are the activation functions. Sigmoid, this is a tanh activation function. So here, maybe this particular operation is generating some data, new data, which needs to be, which is required by the next layer. So you see, this is a plus. So this is added to the memory cell. So this passes on to the new cell like this. Correct. So this is again one operation of tanh. This is second function. And so the output goes out here. Output goes out to the outside one. Output also goes to the next layer. And also the information that will be required by the next layer so that vanishing gradient does not happen is passed, relevant information is passed on. It's passed on and then the layer it comes to. This is how. So there are, if you actually go and read this, there are a lot of PDFs available on this. You can understand how these operations happen. So vector transfer, this is where vector transfer that the data passes, basically concatenation where two vectors getting added. Copy is you are getting copying and then pointwise operation. This is how LSTM, these are like the valves which open. So this is how, this is what an LSTM is. Typically LSTMs are, as the LSTMs are highly suited. LSTMs are highly suited for uh, LSTMs are highly suited for time series application where there is a time component come. They are highly suited for natural language processing applications on this thing. Correct. So this is it. Any questions, guys? Any questions? Any questions here, guys? Haritra, any question? Are you there? Okay. Since that is it. Okay. Now let's see. Let's go back and let's uh, let's see the main presentation. What is there? So that is natural language processing. Okay, I'll just tell you a bit about natural language processing. Natural language processing. I have this thing which will. So let me show you some. These are the layers we were talking about. These are the recurrent layers. Here you see the data is getting back circulated back. This is the LSTM architecture we spoke about. Correct. And these are the use cases. So like Apple's first major tech company. So Apple is using Siri. Siri, as you know, Siri uses LSTM. The Google Voice that you use, that is using LSTM. Uh, Deep learning has over the past year shown remarkable success. Some of the world's most computer science challenges, and Google Voice is one of the LSTMs. Real-time applications like named entity recognition, which is actually a part of the natural language. For sentiment analysis, I told you whether you do sentiment analysis of tweets or or Facebook posts. So sentiment analysis is one of the major, and NLP application which works very well on LSTMs. Correct. So this is it. Machine translation. Google Translate. It works on LSTM front. So that is it. So that's it. I'll just show you some data. I will show you some. This is data. This is code. This is code. And actually, we are here trying to. Uh, this is a code of retail and food services from the US over a period of time, starting from 1st 1992 January to 2019 January. We have the sales figures. So this is the kind of data that we have, which we have put it on a LSTM. This is a LSTM. We'll try to solve this. So initially we are doing some train and split of the train and test and all that, all the processing, data processing that we initially do. Then we scale the data. We are scaling the data so that after we scale the data, this is where we are getting TensorFlow and Keras into it. We are using generators to generate the data for every circle. Here is we are building the model. So we are building a sequential model. We are adding an LSTM network. Here you see LSTM. We are using we are we are using 100 neurons in this layer. We are using an activation function of ReLU. The input shape of the data is given by the length and the ND features. So we are adding one inside hidden layer, dense one, and there's the compiler is Adam and loss is MSC. That means it's a regression problem. So this is where we are actually training the model. We are training the model. So while training the model, we are actually measuring the drop in the loss function. Of the test data and the train data, blue is the train data. So there is some mismatch that we can see in this. So again, we are running the test predictions of the current batch. There are multiple batches, obviously. So we run it, we do the predictions, and this is what it looks like after predictions. So that blue one is the original one, and the orange one is our predictions, which is, if you see, it is good considering that the network is predicting seasonality. It is not, it is not very this thing. Correct. Then we scale the data set. Then we again run it. Fit generator epochs, the 7 epochs. Correct. And finally, finally, here is the predictions beyond 2019. And if you zoom in, you see like this. So that orange is the predictions beyond what is available. This is pretty much good, I would say. And this is using an LSTM network. Any questions, guys? If there's no question, I'll wrap it up. Aritro, are you there? So, okay, guys, if there's no question, I were expecting it to be interactive so that I could have answered question and I had factored in some time. So that is pretty much about this. And thanks for being in. And don't forget to register for EduReka courses because if you're attending the webinar, you get a 20% discount. So webinar 20, correct, is your code. And so no questions, guys. Is that okay? No questions? Auditro, are you there? Auditro, are you there? Okay, guys, then let us end the session if there's no question. Correct. Bye.